After traveling billions of miles in space for the past 4.5 decades, the Voyager spacecraft are running low on power. Power levels for the twin probes have gradually dropped at a rate of 4 watts per year. This means that we won't be able to hear from the distant spacecraft for long, and the historic mission is sadly ending. Over the years, NASA switched off the Voyager's probe's instruments to extend their lives. Following this, where each Voyager was launched with 10 different scientific instruments, Voyager 2 now has 5 in working condition, while Voyager 1 has only 4. And this year, NASA plans to turn off some of the Voyager's remaining working systems, hoping to stay connected with them through their unprecedented journeys till at least 2030. Today, the interstellar probes are the farthest man-made objects in space. But their journey to achieve the unexpected began on a tough note. In the late 1970s and early 1980s, all 4 giant worlds, Jupiter, Saturn, Uranus, and Neptune, align like pearls, studded in a celestial necklace in a long arc with Earth. This alignment happens only once every 176 years, marking the perfect opportunity to send a spacecraft to explore the outer planets. That's because in such an alignment, a spacecraft could get a speed boost from the gravitational pull of each giant planet it passed. With this, a spacecraft's flight time between Earth and Neptune would have reduced drastically from 30 years to 12 years if it was launched precisely by the mid-1970s. Everything seemed perfect, and to take advantage of this once-in-a-lifetime opportunity, NASA drew up plans for a grand tour that would send as many as 5 probes to the 4 giant planets and Pluto. Although the project was highly ambitious, it was expensive at the same time, and hence was turned down by Congress. However, Congress did agree to a scaled-down version of the mission, which was initially called Mariner Jupiter Saturn 1977, or MJS-77. This mission aimed at sending 2 spacecraft to just 2 planets. Nevertheless, NASA's engineers were optimistic. They designed vehicles capable of withstanding the complications of a much longer mission. Furthermore, they hoped their planned route would be extended to Uranus, Neptune, and beyond once the twin probes proved themselves. Eventually, identical in every detail, Voyager 1 and Voyager 2 were launched within 15 days of each other in the summer of 1977, with a prime mission of 4 years, and the rest is history. Voyager 1 reached Jupiter in March 1979, followed by Voyager 2, which had a different trajectory, and arrived in July of that year. The Voyagers took more than 33,000 photographs of Jupiter and its satellites. Some of the most beautiful images taken by Voyagers during their Jupiter trip were those of the gas giant's 3rd largest moon, Io, whose colorful appearance was completely unexpected. Moreover, by that time, the only active volcanoes we knew about were known to exist on Earth. So coming across the moon with 10 times as much volcanic activity as Earth was a big surprise. After exploring the Jovian system, the spacecraft got a farewell kick of 35,700 miles per hour from Jupiter and headed towards their journey to Saturn, where they finally parted ways. While Voyager 1 hurtled through Saturn's rings, going past Titan and eventually heading north out of the plane of the planets, Voyager 2 continued its voyage to explore Uranus and Neptune. In 1986, Voyager 2 found 10 new moons around Uranus and added the planet to the growing list of ringed worlds. Eventually, after the 4 years of the grand tour were completed, NASA planned to turn off the cameras on both probes. This means that Voyager 2's images of Neptune and its moons would have been the last pictures taken by either of the spacecraft. However, when NASA was planning to do so, Carl Sagan made a special request. He urged the officials to have Voyager 1 transmit one last series of images, pointing back at us. So, following his request, on February 14, 1990, at a distance of 4 billion miles, Voyager 1's cameras were pointed backward. The spacecraft captured about 60 images of the Sun and planets, giving the first portrait of our solar system as seen from the outside. Among the mosaic of these images was a photograph of Earth that later became famous as the pale blue dot. This image portrayed our blue planet as a tiny speck against a beam of magnificent light, reflecting how small we are on the cosmic scale. After taking this iconic portrait, Voyager set themselves on a never-ending journey to the unknown. On December 16, 2004, scientists announced that Voyager 1 had reported high values for the magnetic field's intensity at a distance of 94 astronomical units. This indicated that the spacecraft had reached the termination shock and had now entered the helio sheath, a point where the solar wind slows abruptly, becoming denser and hotter. Finally, on August 25, 2012, Voyager 1 became the first spacecraft to exit the heliosphere and enter interstellar space. Then, 6 years later, in December 2018, NASA announced that Voyager 2 had also entered interstellar space. Today, Voyagers have traveled farther and lasted longer than any other spacecraft in history. They are so far away that a one-way radio signal traveling at the speed of light takes almost 22 hours to reach Voyager 1 and just over 18 to catch up with Voyager 2. Moreover, every day they move away by another 3 to 4 light seconds. However, the twins are still functioning. They send data to Earth daily from far beyond the solar system's most distant known planets. As almost everything aboard the vehicles was hardwired, and they don't rely on thousands of lines of code to operate and have no microprocessors. They are the simplest, yet most efficient, one-of-their-kind spacecraft ever built. All the instruments are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But with temperatures dropping fast, keeping the instruments alive is difficult. 2 years ago, the mission engineers turned off the heater for the cosmic ray detector, which had played a crucial role in determining the heliopause transit. Although everyone expected the instrument to die, it surprisingly kept working. The next step is to turn off the magnetometer and the plasma science instrument, which are in the body of the spacecraft and warmed by heat emitted from computers. If everything goes well, maybe we can get the missions extended into the 2030s. However, it all just depends on the power. Even after the Voyagers are muted, their journey through the cosmos will continue. In another 16,700 years, Voyager 1 is expected to pass our nearest neighboring star, Proxima Centauri, followed 3,600 years later by Voyager 2. Then they are expected to continue to circle the galaxy for millions of years. They will still be out there, more or less intact, and who knows that one day they might come into the vicinity of another civilization and can convey our messages to them via the vintage golden records on board them. The golden records contain images and sounds meant to give some sense of the world the Voyagers came from. These include pictures of children, dolphins, dancers, and sunsets, the sounds of crickets, falling rain, and a mother kissing her child, along with 90 minutes of music. Voyagers have changed our understanding of the universe. Considering that the missions were originally planned to last just 4 years, they have exceeded everyone's expectations. But the clock is ticking for the iconic spacecraft, and one day they will be out of the range of the Deep Space Network, diving into a sea of eternal silence. Do you think the Voyager mission was the most successful one in history? Let us know your thoughts in the comments section. And if you enjoyed this video, make sure to like it and subscribe to our channel for more.